how to write a conclusion on all of our data that we collected is I already set up all our data. This is Motion Lab, Basic Motion Lab Part 2. Here's all the data, trial 1, trial 2, trial 3. That is the, right here is the position versus time graph, and then here is the velocity versus time graph. I have like what we needed. I have to delete this because I already got it down what we needed for there. So here, and then we're supposed to have tables for initial position, final position, total time, average velocity, average acceleration or acceleration for each of them, and the average acceleration for them all. Alrighty, and so now we get to write a conclusion on our data, right? So our conclusion, and in LG Learning Goal 5, I did how to write a full conclusion. So how to write a conclusion is when you just say what your data is, like what your data shows, in a little, like a little summary of what your data shows, right? It's gonna be quick, like maybe 4 sentences top about what our data shows. Our data shows that there was, in these graphs, we'll zoom in a second because I made them smaller because they're in that. Our graphs show that the position versus the position went down because we were on a ramp, so the position went downwards on the ramp, right? It started at one position away from the sensor, so then it went down and it moved to the other position. Each of them are like that, but all of them are different because some of them are quicker, some of them are not quicker. This one's the longest one, this one's the second longest one, this one's the shortest one, I think. I think this is the longest one, but middle longest, second longest, third longest, or that's the shortest. So don't know because all I can see is this. So okay, and then our table shows that they all started at different, and most of them were, if we rounded up, we would be getting to 1, like how this one is. And so the final position was, they all were nowhere near 1, but one was 19, 17, 18, and 17. Yep, middle one was the longest, first one was the second to the longest, and the last one was the shortest. Alrighty, and then when we did these, the velocity shows that it gained acceleration as it ended, and then when my partner stopped it is when it lost it. Like, all of them had lost it at some point. This one's a little more wobbly than the other ones, but, and then the average velocity was these numbers, and the acceleration, they were all negative, so they were all slowing down, because as we know from for graphs that show stuff, when they go below that line, the bottom line, the x-axis, is when they're speeding up in the opposite direction. So there's that. Alrighty, yep. Average velocity, acceleration, and average acceleration. We gotta put a comma there for proper punctuation. And now we get to our conclusion. So how we should write our conclusion is so he says to summarize my data and results in the first few sentences. So the data we have is the data, we'll say the data shows, that gives us an easy first 2 words. The data shows that it got closer to the sensor as it progressed on the ramp. It got closer to the sensor as it got closer to the sensor as it progressed through the ramp. On the ramp. There is one sentence that just summarizes these three of them. I'm pointing on the computer, which you can't see, so sorry about that. Alrighty, and then it also yeah, it got closer to the sensor as the time went on. So that's why position goes down, because that's how far it is away from the sensor. Yep, because neat little meter readers. It's a meter away from the sensor at first, and then it slowly progresses to get closer to it. And with each of these, we didn't put any force to it, we just let it go and let it go down the ramp. Right? And so the initial position, we'll say the positions are quite similar. The first positions are quite similar as when it started going down, because they all started the exact same. They all started the exact same. Some were it's just W-E-R-E, were a little late. Waiting for logger pro. Because that is what happened when we were doing it. So some were a little late due to waiting for logger pro, but we shouldn't actually say that. So we'll say exact same, just some had more kinetic energy as they went down. K-E-N-I, kinetic energy as they went down. So they went down. Alrighty. And after that, so after they went down, and so there's two sentences. We're supposed to go maybe to 4 at most. And those are just explaining the first 3 graphs in the first table. Now we're on to the results. Right? Alright? Because it's still data that was given to us that we either had to figure out or that we already had figured out from our resources. So graph 4, 5, and 6 show the velocity versus time graph for each of the trials. And so we will say, since when they go up, that is when my partner had stopped them. So we will say in the data of the first 3, by our first 3 graphs, right? In the five through 4 through 6, in graphs 4 through 6, 4 through 6, it shows at the end, and when the car got stopped, and it also shows and that it gained acceleration as it went down the down the ramp. Alrighty. And that just explains those first 3 in just one sentence. Those second 3 in graphs in that one sentence. And now we get to do this. All of the exhilaration is pretty much the same because they were all like the same time, and so is the velocity. So we'll say the velocity with table 2, all of the numbers are really similar, right? Numbers are similar due to not much change happening. Not much change happening with it. Due to not much change happening with each trial. And none of this has first person in it. It is really just explaining what we did and what the conclusion of the data and results are. So that is all for what the data and results are, since that's all this learning goal asks for. But then after this, you would just write like your possible errors in one concluding sentence, saying like what did this tell you about motion, basic motion. So there you go.